Hello! This video is about atoms and light, specifically emission spectra and the Bohr model of the atom. First, here are a couple of really beautiful chemical phenomena. First, flame tests. If we got to do this together in class, that would be amazing. This is one of my favorite things to look at in all of chemistry. When you make metal salts of different metal ions, and you put little bits of that salt, of that metal, in a Bunsen burner, it glows this beautiful colored flame. You can see that barium glows green, strontium red, lithium orange, sodium yellow, copper a different shade of green, potassium this purple lilac color. It's really beautiful to see. And what's cool about this is, one, that there are different colors, but also that these different colors are consistent. So any kind of sodium salt, whether it's sodium chloride or sodium sulfate or sodium nitrate, it will always glow that same yellow. Sodium always glows yellow. Copper always glows green. Why is that? Here's another thing. Neon lights that you've probably seen, either in pictures or in person. Here's Nashville, Tennessee, up at the top, or a picture of Hong Kong at the bottom. Why are these called neon lights? Well, neon is an element, but these lights aren't all neon. Neon glows red. Neon only glows red. So all of these other different colored lights come from different elements. You can put any gas in a tube, run an electric current through it, and it will glow a color, but the color depends on the element. Here's helium, neon, argon, krypton, xenon, all glowing different colors when you run an electric current through them. Why is that? So here's our first key observation. When they're excited, when you give them energy, whether in the form of flame or an electric current, elements glow different colors. And elements always glow the same color. Neon gas always glows red. Sodium metal always glows yellow. Copper metal always glows green. Why is that? There's more. If you remember from physics, when you shine white light through a prism, it refracts. And when it refracts, it separates into all the different colors of the rainbow. White light is not just one color. It's a combination of many, many colors. You can do the same thing with the light coming from an atom, from an element. So on the left, here's a tube of hydrogen gas, which is glowing a pretty purple color. But when you shine that purple color through a prism, just like the white light separates into all the colors of a rainbow, this purple light also separates into 4 distinct colors. This is called an emission spectrum. It's not the complete rainbow spectrum, it's only specific colors emitted by this particular element. So hydrogen glows 4 colors: violet, blue, blue-green, and red. This purple that we see is actually a combination of those 4 specific colors. Furthermore, you can find the emission spectrum of pretty much any element, right? So you can see hydrogen is the second one down. You've got those 4 colors, but sodium has an emission spectrum with a lot of yellow, but also some light blue in there. Calcium has a an emission spectrum with many different colors. Mercury also has an emission spectrum with different colors. So our second key observation, these colors that we saw at the beginning is not just one color. It's actually a combination of multiple, very specific colors. And that combination of colors is always the same for that element. So hydrogen always glows purple, but really hydrogen always glows 4 specific colors. Here are the questions that our new model is going to try to answer. 1, what makes elements glow? 2, why do elements always emit the same combination of colors? And then relatedly, will they ever emit a different color? These are the questions we're going to explore in the next video. Thanks for watching.